हम स्टडिंग एब्रेसिव जेट मशीनिंग। एब्रेसिव जेट मशीनिंग में कौन कौन से आते हैं, जैसे वाटर जेट मशीनिंग, एब्रेसिव जेट मशीनिंग। वाटर अकेले नहीं, वाटर अकेले हो सकता है पर एयर अकेले हो मशीनिंग नहीं कर सकती। वाटर जेट मशीनिंग कैन बी देयर बट देयर कैन नॉट बी प्योर एयर जेट मशीनिंग। As hardness of the working increases, material removal rate decreases. This unconventional machine is mostly used for brittle and fragile workpiece. Yes, here the hardness is method material rate is equal to C into V raised to 1.5, where C I will show V is equal to velocity of the abrasive particle. C is function of number of abrasive particle imparting the workpiece per unit time. Q flow rate of abrasive particles, diameter of the abrasive particles, density of the abrasive particles, and hardness of the abrasive particles. So as the hardness increases, MRR decreases. So hardness नीचे आएगा और डेंसिटी ऊपर आएगा, नंबर ऑफ पार्टिकल्स भी ऊपर आएंगे और डायमीटर भी ऊपर ही आएगा. सो दिस फॉर्मूला हैज़ कम फ्रॉम डायमेंशनल एनालिसिस. C will be provided in the question or the formula itself will be provided in the question. Energy released by jet half mv square, of course joule में. Energy released by jet per second half m v square, where m dot v square, where m both here m represents abrasive particles, because abrasive only releases the energy and only abrasive can cut the material. So here m is abrasive, here m is only abrasive, because the jet is made of two things, carrier gas plus abrasive. So here the mass of abrasive only. Yes, only mass of abrasive, as only abrasive removes material. So mixing ratio is the volume of abrasive or volume of carrier gas. Total is equal to abrasive plus carrier gas. Some most important graph, MRR mixing ratio is this. Nozzle tip distance. Nozzle tip distance between workpiece. Here it is nozzle, and here this nozzle tip distance. This Q is the mass flow rate of volume flow rate or mass flow rate of abrasive particles. This is the question. This is the simple question. Consider horizontal and as we know in impulse turbine, pressure at exit is equal to P atm, which we consider 0. This also, in this question he has told to conserve the momentum, or sometimes he tells to conserve the energy, but if nothing is given, conserve the momentum. This is any day for every machining, this is valid. Process parameters: brittle fracture, Al2O3 SiC, nozzle tip distance 0.25 to 0.75 mm. Critical parameters are abrasive flow rate, velocity, nozzle distance, nozzle tip distance, abrasive grain size, and jet inclination. This is ultrasonic machining. By vibration of tool, first tool vibrates, then there is a slurry which vibrates due to this type of vibration of tool, and as the slurry vibrates, the workpiece vibrates and it removes the material. This can be used for any type of material, maybe conductive, non-conductive, brittle, non-brittle, but most useful for brittle. MRR is number of abrasive particles, slurry में abrasive particles, because slurry vibrates means abrasive particle vibrates and it removes the material. Frequency of vibration of tool. Tool feed means vibration of the tool. Tool feed means vibration of the tool. A tool feed means something tool comes down. I don't know. MRR, amplitude of vibration of tool. Okay. Electron beam machining. Electron beam machining, there is a necessity of vacuum. Vacuum is at most necessary. and electrons are removed by tungsten. For like something are placed here, so the electron flow falls only on workpiece. This laser beam machining, a vacuum is not necessary. Now this is an important question. You see this unit, mm cube per ampere second. Mm cube per second is volume flow rate, MRRV. Upon I defined something as MRRS. So MRRS is equal to MRRV upon I. So MRRV is equal to I into MRRS. First of all, no, this is electroplating, and it does not uses that EI upon rho F. It does not uses that formula, because first of all E is not given. E is not given. Faraday's law is only valid for electrolysis, electrochemical electrolysis. Yes, this is also electrolysis, but E is not E of workpiece we need. Here workpiece is steel. So steel, how can we find the E? Atomic weight of steel is easy, but at valency of steel. This is how to solve this, but I suggest you find MRRV, equate the units. MRRV is equal to MRRV. MRRS into I is equal to thickness into area removed. Do from here. I have done this question here.